Okay, looks like I've messed up and I've pressed the stop button there. This is obviously then part 2 of this paper. Sorry about that. Show the equation 2x cubed plus 4x equals 3 as a solution between 0 and 1. Now I like when I'm doing iteration questions for this to equal to 0, so I'm going to bring that over this side. So I'm going to go 2x cubed plus 4x minus 3 equals 0. And then what we do is just let x equal 0. So we get 2 lots of 0 cubed plus 4 lots of 0, take away 3 equals minus 3. And then when x equals 1, you get 2 lots of 1 cubed plus 4 lots of 1, take away 3, and that's going to equal 3 as well. Now change of sign, so change of sign indicates a root between x equals 0 and x equals 1. So that's why I'm going with that one. Show that this will rearrange. Now notice there's an x cubed over here, there's an x cubed there. So I'm going to bring that over this side to start with. So I'll get 4x equals 3 minus 2x cubed. And then I'm going to divide by 4. So I get x equals 3 divided by 4, take away 2 divided by 4, x cubed. And obviously 2 over 4 is a half. So this is equal to 3 over 4 minus x cubed over 2. Okay, so the same thing. Right, the way this works is we do on our calculator x equal, we type the 0 in, and that's going to give our ANS. Then we've got x1 equals, and we just write this equation in, so 3 over 4 take away ANS cubed over 2. And then we get the answer. Use the iteration times to find the estimate of the solution. It doesn't tell me how many times. I think this might have just been an error when they typed this up, because they usually tell you a number of times to do it. Use the iteration formula times to find an estimate of the solution. So they missed off what it is there. So let's go with the question. So all I do is I type 0 in, press equals, and now the ANS is 0. Then we type in the equation, so we go 3 over 4, get out of that bit and put a take away, and then another fraction, ANS cubed over 2. And then you press go, and you get 3/4 for the first answer. So x1 equals 3/4. x2 equals, and I'll do it 3 times I think, x2 equals, so just press equals now, and you get 0.539 going on forever. x3 equals, press it again, 0.6716 going on forever. So I'm going to say it's about 6-7. Well, you can just press it loads of times actually. So every time you press it, you should write it down. Though. So let's just keep going. 0.59848 going off. X5 equals 0.64281. X6 equals, it's not a big deal, 0.61719. X7 equals 0.63244. x8 equals 0.62351. x9 equals 0.62879 going on forever. x10 equals, I think it's the last one we'll do because I can't bother no more, 0.62569 going on forever, and you can see these two round to 6.3, so I'm going to say x is approximately 0.63. Okay, that's where I'm going to stop. Question 17. Oh, got a vector question. Oh. So we've got x is the point on AB is x, such that a to x is 1 and x to b is 2. So x is about there, say. So let's say that's x, and that's 1 and a 2, so that's 1/3 of the way up, and that's 2/3 of the way up AB. So first of all, I'm going to work out AB. So a to b. A to b is equal to, what's a to b? So you go back that way and then up there. So it's minus 3a plus 6b. Okay, so minus 3a plus 6b is a to b. And that means a to x. So a to x is going to be 1/3 of that, of minus 3a plus 6b, which is obviously minus an a plus 2b's. So that's a to x. Okay, prove that x is a point AB such that, prove that c to x. So c to x now, so c to x is equal to, come across there, so 3a plus a to x, so plus minus a plus 2b's. which is 2a's plus 2b's, there's c to x, and is something to do with c to y. So c to y is going up the 6b's and across that way. So c to y is equal to 6b's plus 5b's minus a b, 5a's minus a b. So that's 5a plus 5b. Okay. Prove that c to x is 2/5 of c to y, so 2/5 of it, so 2/5 of 5a plus 5b is equal to 2 lots of a plus b, which is equal to 2a plus 2b, and they're the same, aren't they? So, and therefore c to x is in fact equal to 2/5 of c to y, which is what you're trying to show. Okay, next one. We've got graphical information v, speeds per second of a car t seconds. So if it's a speed time graph, the area underneath is going to be the distance travelled and the gradient is going to be the acceleration. So what's the first thing I'm looking for? T equals 15, so I want at this point, I want a gradient at that point. So first of all, I'm going to draw a triangle in, not a triangle, first of all I'm going to draw a tangent in hopefully. So I'll draw quite a big tangent in, I'm going to go to there I think. For no reason. So it starts at there, which is at 5.5. So I've got 5.5, and then I'm going to end up over here somewhere. So let's just draw this triangle down here, and then come across. So there's my triangle for this thing. So where does this finish at? So it looks like 22.5 for me. So 22.5. So it looks like I've gone 17 across, and the rise up has gone from 10. So 10 up to, what's that, 24, about 24. So that's a rise of 14. So I've risen up 14. So estimate the gradient is the rise over the run is equal to 14 over 17, which I guess you can do on your calculator. 14 over 17, press equals, is equal to 0.8235, going further. That's my estimate. And it represents the gradient on a speed time graph is the acceleration. That's what gradient represents on a time graph. Work out an estimate for the distance the car travels in the first 20 seconds of its journey. So that's the question. So I'll go back. So first 20 seconds. So I want to go to the first 20 seconds of the journey. I want to go to that point. And I've got 4 equal strips. So the area under the graph is the distance you travel, so 5, 15 there, and now here. Okay, so what you're making is you made a triangle for the first one, and then every one after that one are just trapeziums. So trapezium, trapezium, and another trapezium. Okay, we need to know the heights of these things. So for me that looks like it's 4 on that one. This is one is 10, 11, it looks like 12. Possibly, yeah, we'll go 12. This one looks to me to be about 17. And this height looks to me to be about, can't see that, that's 20. Is that 20? I'm going to go 20 there. Okay, so we've got a triangle with a height of 4. And that goes from 0 to 5. We've got our first trapezium, which goes from 5 to 10. It's got a 4 there, and the next one is 12. And then we've got a trapezium, which has gone from 12, 10 to 15, and a height of 17. And the next one was a trapezium again, 15 to 20. There's the 4 equal widths, 17 and 20. Okay, so the area of a triangle is the base, a width of 5, so it's 5 times the height of 4 divided by 2. I'll come back to all the calculations in a second. This one, the area of a trapezium, is at the parallel side, so 4 plus 12 times by the width, which is 5, and then divide by 2. This one is 12 plus 17 times 5 divided by 2, and the last one is 17 plus 20 times by 5 divided by 2. Calculate the time. equals 5 fours are 20 divided by 2 is 10. This one 16,840. This one's a little bit harder because you've got all stupid numbers. 12 plus 17. Put that in brackets. Bracket there. Times by 5 divide by 2 is 72.5. And the last one is 17 and 20 times by 5 divided by 2, and I've got 92.5. And then to get the total area, you just add these together. So 92.5 plus the 72.5 plus the 40 plus the 10. And that gets you a total of 215 metres is approximate distance you've travelled. And that's it. Sorry, I think we've broken that into half. I don't know what I pressed there, just weird.